I kind of like this problem 39, a nice little optimization type problem. You're going to make a cubic box. You're going to make a box, a square base with no top. Let's see if I can draw that in here. That's good enough. So no top, open top. I think that's the picture I've got here, in a square base. So B and B would be my square. Let's see if I can get this drawing in there for 39. We want a square base. So that's my base. That looks like a side. That looks like a side. How's that look? With an open top? Sure. Let's call that a square. B by B. And we've got to have a height. Good enough. Square base, no top. The material for the base is $3 per square foot. Material for the sides is $1 per square foot. We want to write an equation for the cost of the box as a function of x, the length of one side of the base. So I guess that's not a b, that's an x. Makes sense. And then our height is, it's got to still be h. Write an expression for the cost of the base in terms of x. So the cost of the base, the area of the base, is x squared. And where that's square feet, so the cost of the base should be 3x squared, $3 times each square foot. Express the cost of the sides in terms of x and h. So we have 4 sides, which because of the square base are each x times h, and they are $1 per square foot. So it's really 4 times 1 times x h, but let's just call that 4x h. Express the total cost of the box in terms of x and h. Well, that's just going to be 3x squared plus 3x squared plus 4x h. Use the fact that the volume of the box is 100 cubic feet to eliminate the h from the equation you just wrote. So volume is another equation. There we go. We need another equation. Volume is x times h, and its volume has to be 100 equals x squared h. So h equals 100 divided by x squared. Substitute that here. My cost is going to be 3x squared plus 4x times 100 over x squared. And I wouldn't get hung up trying to simplify that. Graph the equation and find the value of x, which gives the minimum cost. So we get that graph with a good window. First quadrant should look something like that. So we've got our minimum cost right here. And I think the x value to that is 4.055, which would be in feet. And then the minimum cost would be the y value of $147.97. And the question is asking for find the minimum cost. So $147.97. Good problem, reviewing kind of our chapter 7 optimization type stuff.